guys, or good morning. Today we are going to continue our stream with Pygame. Let me just make sure that you can hear me properly. Alright, let's go. So, let's start. Okay, so we'll continue the same game that we were making the last time. So, we needed to implement today the time to live for the bullet. But before this, let's just start with to see the point, the actual point of the game. Okay, the game does not make sense actually, but who cares? We are almost ready for Steam release, by the way. But so let's just start. By the way, I was actually implementing the GitHub page, so you can all have access to the source. So let's just fix it right now. Okay, so GitHub just created the yet another game. Okay, so git status, git init. No, is already init initialized, so we have to actually wait, what? We have just the okay, we have the first setup, so we can just push everything, but where? We can push it on the okay, let's set up the main branch and let's add the remote. Alright, and then remote already exists, but well, it's good. Okay, I think that everything is online. Let me check, or maybe not. I didn't add the origin. Origin already exists. Let me check. Git verify origin. I don't know. What have I done? Okay. I already have a Git repository. I didn't remember, so I will just delete this repo. Let's go. Let's go, ski. Yes, sir. Maybe you can just copy and paste it. Yes. What? Okay. Alright then. So this is the repo. Python to the shooter. I will set it, put it on the chat. Okay, so let's try again. What is the status of the game? Is the blue cube with the wrong direction bullet? No, it's not wrong direction. The diagonal direction is wrong actually. The bullet should follow the diagonal movement, but is not doing it. So, but this is not a problem. So we can just go straight to the time to live for the bullet. Actually, okay, time to live. We don't have actually a time in the game now. Indeed, we have the delta time, which we are calculating it here, which is just the difference from the last time and the actual frame, the last frame and the actual frame, actually. So maybe it's not the correct description. It's actually the difference between I don't know, difference between frames. Who cares? Okay. So delta time is the time that we have available for our game. So we need to pass it. Yes, in the drawing method, I was already maybe I was already doing it correctly. Okay, draw. We need. So we have the delta time. Let's just print the delta time to see what we are dealing with. Ah, yes, because we are not. Yes, as you can see, we are now like printing. Which. Why is negative? Wait, is negative. What the fuck? Is negative. Let me check. So delta time we have now, and we have last. Well, okay. Delta time is now minus last frame, obviously. Okay, now should be correct. Yes, now it's correct. So we have a measure of time in our game, which is not really helpful right now, because it's in milliseconds, as you can see. What we can do is to, well, it's not a problem actually. We can use milliseconds to make stuff in our game, which is more far more precise than seconds, for example. Because if we just multiply delta time for 1,000, we can just have it in seconds. But this is not the point, because you know, making stuff every second is not funny, I guess. So let's just take this value and define a, I don't know, like something like yoink, something like a time to live. I was doing that the last time, I think. We can just say, I don't know, every no, wait. Let's just use seconds. Seconds are better. We can say, okay, time to live. We can say something like every 0.3 seconds, we will just delete the bullet, just to test if we can actually delete it in the screen. So what you can do is, well, for now we can just stop to draw the bullet. I don't know if there is actually a way to remove it from the list, but we will care about it later. Who cares? So let's just start. We have the delta time here passed from the main scene, which is in the main file actually. What we can do, so we are already passing these values. We can just say, okay, bullet, if time to live, wait, we need a counter, we need an in-class counter, something that every instance has. So let's create another instance variable, something like counter. Okay, so if counter is measured in time to live, we can just say is bigger than time to live. We can just say yes, self.time to live. We can just no, wait, if it's not, okay, if it's not, we draw the game, the bullet. Else we will just for now we'll just reset the time to live, I guess. No, okay, let's just stop to draw. So if the counter is not greater than the time to live, which we defined, we draw the bullet. This should work, but let's just print the counter, just to be extremely sure. We have also to obviously to add the delta time to the counter, so we can just say self.counter plus equal delta time. Okay, let's just see. Let's start with a bullet, just a bullet. Maybe it's too much. By the way, it's working. It's actually working, which is weird in software engineering, that something is working like the first attempt. So extra lol with double sauce. This is what makes me happy. Okay, now that we have a fully functional RPG, we can just publish it on Steam, but the next time, okay. So, okay, what can we do now? We can say, well, first of all, we need to create a system that will delete the bullet, because, you know, we can just add to a list the bullet, like, many times, but this is not the... What is direction? Wait. the heck is direction? Direction is a tuple, is a class. But we don't need direction. Wait. Up, down, left, right. And was used for the player, I guess. Yes. Okay. Just a little recap, because I don't remember, dude. So, if we are keep press the up keywords, keys, we are setting the direction, and based on the direction, we are actually increasing the respective axis. Okay, let's go, dude. Let's just push. Okay, now, time to leave is working, but he is not deleting the entity, actually. He's just stopping to draw the actual bullet. We can verify this by saying, okay, every time we spawn a new bullet, so here, actually, we print the actual bullet's number. So we can just say, okay, how many bullets we have now? So let's just print the number of bullets. Let's just print the length of the bullets list. Okay. Okay, yes, we need the... okay, let's use the format string. Yes, as you can see, we are just increasing the number of bullets, which is weird. Which is freaking weird, bro. So... okay, so... how can we just delete a bullet when its life is ended? We need to create a system, something like a bullet manager. Well, if we have to design a fully functional game, we will probably have to design something like a bullet manager. So, like an entity to... how can I say? An entity to... let me translate it, dude. I'm not an English crazy ass dude. To question, yes, to question. So we need an entity to question each time we need to spawn a bullet. This entity will take care of spawning this bullet and will take care about the eventual deleting of the bullet. Because for now we don't have like... okay, we can just delete the bullet if the time to live has ended. But inside the class, I don't think that this is possible. Because how can... so, in Python, objects are basically just a reference to... just a reference to an object. Sorry, objects are like... I don't know, if we have the same object in 3 instances, we have just a counter that is increasing over these over this object. We have reference counting, basically. So what we can do, actually, we can just remove from the list the object, the last, I don't know, one of the bullet, which has the time to live expired, and then the object will be cleaned by the garbage collector, I think, because each bullet is different. I don't know, brother. So, by the way, let's start with this new system. Okay, for now we will make a tailored manager, something like which is not useful for other entities, but just for the bullets. So we could call it for now like I don't know, bullets manager. Let's just bullets manager, like maybe spawner. I don't know. Let's just call it bullet manager. I don't know why. I think that I'm somehow over-engineering this system, but who cares? We will see. Okay, bullet manager. Alright, so bullet manager will actually have to spawn and destroy this entity. By the way, I'm already seeing a possible common pattern for the future. This will not be a class, this will be or a base class or something, or a component, I don't know. Okay, so what we spawn? We spawn an entity. Yes, I'm already over-engineering everything, but who cares? And we destroy the same entity. Wait. I'm doing something weird. What is spawning for a bullet? What a bullet need to spawn? Basically need this stuff. So need a position, actually, a starting position and a direction. Okay, a starting position and a direction. And the direction to go, basically. I don't know, brother. I don't freaking know. So, we have a structure here. Spawn and destroy. Spawn. Okay, so let's import the class, the bullet class. So, blue. Okay. Now we can just request these informations, but let's just remove these bullets, all this stuff. Okay, and we replace it. We will replace all this stuff with the bullet manager. Yoink. Okay, now we need to instance the bullet manager, which is a first class citizen like. So we just say bullets manager. All right then. Now let's just use its method. Its methods. Bullet manager dot spawn. For now, accept nothing. And okay, but when we destroy a bullet, this is weird. This is weird. By the way, okay, bullets. We don't have bullets yet. We have to move it to another class. So, okay, all this stuff, we need to instance a new bullet. So let's just implement the spawn for now. For now, we have the spawn with the starting position and a direction. So we will just ask for these informations. So starting positions. Wait, microphones is getting weirder with wires. Okay. So we need the starting position, starting pose, and then the direction. Direction. Okay. You know what? When someone make games, actually pass the measure the most of the time by implementing systems, and this is like a system. This is basically a spawning system, but I think that is necessary because we can have like more fun by spawning also their stuff, but we will see in the future. Who cares? So okay, let's just spawn the bullet. So we say just starting position and direction, and that's it. Basically, we need to take care of the bullets. So we can just say we can just add the bullet manager. By the way, will be a singleton. So we can just say instance equal none. A singleton basically is a class that you can just instance one time per application life. So we can just say that in this game we will just have one bullet manager, just to don't confuse the instance. I don't know, who cares? I don't remember how to make a singleton in Python. Let's just singleton Python. Getinstance, okay. So we'll just call the getinstance class. Ah, the new method, the new dunder method, which is the method call called when we instance this an object from a class. Okay, so we just okay, let's try to implement it by our own. I obviously don't remember anything, so we will just follow the code. Okay, so we need the class, which is weird because you know. Okay, we need the class, the args, and the quarks, keyword arguments. Okay. So if we don't have an instance, we just instance a new class. So if not instance, class dot instance class. Okay. So let's just implement it. If not in instance, if not self, I think. Oh no, maybe class dot instance. We just create a new instance, if I'm not wrong. Okay, we assign a new object. Object.new. This is weird, by the way. This is pretty weird. Okay, he's doing here he's doing the same thing as above, basically. Okay, the decorator maybe is better, by the way, because we can just decorate a class and will be automatically a singleton. The cons are, while object created using my class will be singleton object, my class itself is a function, not a class. So you cannot call class methods from it. Okay. So basically we will not be able to call static methods, if I'm reading correctly. While object created using my class will be a true singleton object, which is what we want. My class itself is a function, not a class. So, okay, so my class become a function. No, this is extremely weird, because yes, this is basically wrapping the instance, the class instance. This is not the best method either. Module, what the heck? Decorator returning a class with the same name. No, this is this is not the best way. Okay, let's just continue with the class, with the base class type. The base class, yes, which is what we want. Okay, so class.instance equal, if not is instance. Wait. I don't know. By the way, it's not necessary. I'm just getting crazier and crazier. We will take care of it later. Who cares? Okay, now we have the spawn method, which is should work. We just need to pass the player position and the direction, which is working. Let's just create a new instance class, which will take care of the bullets list. So self.bullets. Let's just initialize it as empty. Self.bullets. Append. Let's append a new bullet. Okay. And this is pretty easy. Okay, now what we need is to find a way to destroy a bullet. But, you know, destroy something is like we need a reference to it. Okay, maybe I'm over-engineering the program. Because destroy is not adding any value to the previous structure of the... Who cares? Let's just continue. In the future we will need it. So, okay. Bullet manager should work. We need a way to destroy the bullet, but I don't know how can I do it. I really don't know. Maybe we can what we can do is to actually... We need to remove the bullet from the list, but we can't inside the bullet. We can't from inside the bullet. We need a system that will check if the time to live of the bullet has expired, which could be just a flag, for example, inside the bullet. I don't like flags, by the way, because they change the logical flow of the program in difficult to debug ways. So I don't know. Let me check. Yes. Okay, probably we will go for the flag. Because if we... Wait. I have a solution. We can just move the time to live outside of the bullet, so the external entity, like the bullet manager, can handle the timing, the time to live of the single bullet. We can just do it like that. For example, we say, okay, bullet manager, just when I spawn the bullet, give me the time to live of this bullet, if it makes sense, which has a default. For example, time to live will have like, I don't know, 0.5 default value, and we can just say, okay, this bullet is not anymore just a member of a list, is a member of a dictionary, so we can have more information per bullet. We can say, okay, bullet, so this is no more, this is a basically this is a dictionary, so we need to say, okay, bullet, let's just create an ID for you, and we will just assign you to the bullets dictionary. How can we create an ID? We have to create a new class, like something like ID generator, and this class will generate a new ID each time his method is called. So generate ID, and we just return a new ID, an incremental integer, so who cares. We just say, wait, I want it oh no, okay, we need a state, because I don't know, maybe we can do it static, this class, a static class. Let's just don't overcomplicate the reasoning. So we just say last ID is equal 0, which is the default ID, and we just say that last ID is plus equal 1, and we just return last ID. That's it. So basically, we increment each time the method is called, we increment the ID, and we just return the new ID. Okay. By the way, this will be an utility, something like an utility. So let's just create an ID generator file, module, and let's just import the ID generator. Okay. Now we need to instance the ID generator. You know what? Maybe we can just... okay, no. We will use the static generator as a class 2 instance, as an object, not as a static class. This is because if we use the ID generator for other fields, like now we are using the ID generator for the bullets, okay, this is one for the bullets. But what if we instance a new ID generator for another system, like, I don't know, an entity system, for example, an enemy system? We will have to increment an ID, but for this system. For now, we will have an ID generator per system, so we can't have a static global class, I don't know. So let's just instance the generator. So ID generator will be a new ID generator, and the bullet will require a new ID. Okay, now is green, as you can see, because we are shadowing the ID keyword, okay, of Python. So the best will be to just put an underscore before the name to prevent Python to say, oh wait, you are shadowing one of my feature, you know. which is not important. I don't think that we will use an ID here, but who cares? One of your possible question could be, I don't know, I'm not watching Twitch right now. Okay, one of your possible question will be why we are not producing an hash of this ID. This is because it's not necessary to have for example, a universal unique identifier. In this case, we just need to have an internal, for the bullet system, an internal unique identifier. And the ID generator class is producing a new identifier. So let's just continue. What we can do? We can just say, bro, just give me a new identifier. So generate. Let's just remove ID. Generate is better. You know, when we create a new method, I hate when people just rewrite down the name of the class. For example, in this case, generate ID. Okay, but we are in the ID generator, dude. It's obvious that you are generating a new ID. So let's just delete ID. Okay. For the field, by the way, for me is not a problem, because if we have multiple fields, the more explicit you are, the better, the more clear the program is. So last ID for me makes sense, even if we are in the ID generator class. But the generate ID doesn't make sense, it's redundant. So let's just generate the new ID. We have the new ID, we just pass the new ID to the bullet. Now we have to register the bullets on the bullets dictionary. Bullet dictionary. So let me think, because we need to actually create, but by the ID of the bullet. Something like that. I'm not sure that the ID makes sense now in this phase of the development. Because, you know, maybe to delete a bullet, we can just iterate. We can just iterate over each bullet to check if the time to live has expired. So we can just have a list. You know, okay, maybe the ID generator is useful, but the bullets maybe could be just a list for now. Okay, let's just use it as a list for now. I have another idea. So for now we just add the bullet. And what we can say, we can actually is, okay bro, let's just create a private method to just check if the time to live has expired. For example, we can just say a method called has expired, for example. Has expired. No, wait. Okay, the bullet will not know about its time to live. The bullet manager keep track of the time to live of the bullet. Okay, so okay, let's make it simple. The bullet, okay, the most how can we say? The best idea is to actually don't let each bullet, to know about their time to live system. This is the best idea, because we are decoupling the bullet from the I don't know how the life of itself. Okay, and this is what I'm trying to implement. But the issue is we can't use a list. We need to use a dictionary. Dictionary in Python, in the last versions of Python, is ordered by default. So we can just iterate over the dictionary, because as the first bullet that you add has more probability to be the one with the less time to live remain. Okay, by the way, I'm tripping out again. Let's just create it as a not as a list but as a dictionary. Software engineering is crazy, dude. We just add the bullet. We will add the bullet with. So we need a value and a key and a value. The value will be the ID generator, okay, the ID. This will be the value. So, and the key. The value will be the bullet, but so let's just represent this dictionary for a moment. We will have something like 1 and the bullet ID, basically the bullet. But we need to associate even the time to live. So we actually need to have something like a tuple, which is time to live. The problem here is not is not an efficiency problem. It's like, how can I represent the bullet in the more clear way? So if I just see this code in like 1 month, I know exactly what it is doing. I don't know if it's clear enough, but let's just implement it for now. So we will just say the bullet and the time to live for now. Okay, something like this. Let's just leave this example here for now. By the way, if we need an example, it's not clear enough, I think, but who cares? Is getting me crazy, this engineering decision, but Okay, so now let's just create a method to check if the bullets are expired. Now we have to take another engineering decision, because we have to create a new rule for our program. We need to decide to call a method from the scene that will check if there are bullets to clean. So we can just say just create the so we have already the spawn method, which we will call it on demand. If we press space, we will call spawn method, and the bullet manager will spawn a new bullet. But we need a draw method, this for sure. And this method, we will just iterate through every bullet and just call its draw method, which is fairly easy. So we can just say for bullet in self.bullets.items, and we can just say not items, maybe we don't care about the ID here, we can just say values, and we will get the tuple in return, so bullet and time to live. Now we just draw the bullet, so we don't care about the time to live. So let's just say bullet.draw. And by the way, maybe here the type of annotation will be useful. I don't know if it's the correct way to declare the type. Yes, it is. So here we now have the draw method declare, maybe. Bullet dot, no draw method. Self.bullet, because values maybe is abstracting the dictionary. Wait, I just wrong the annotation, because we need the typing module. From typing import dict. And now we have a dict of bullet. I don't remember, is like that? Maybe it's correct. Nope. Maybe I'm just getting crazier again. I don't know. Dict of object. Oh, I've opened. Okay, my PC will definitely crash now. I've opened Android Studio. Holy. Okay. And okay, so Python dict annotation. Yes, is the correct way to declare it. So this is correct. All right. Okay, now we are adding the bullet to the bullets list. We are saving the bullet with its time to live, and we are drawing the bullet. Okay, so now what we can do is actually create a method to check if there are bullets to delete. So let's just create clean old bullets. Who cares? I mean, is not obviously a good way to design a so specific method, because here is just doing a specific action, but who cares? So for bullet in all this stuff, we just say, okay, time to live. So if clean old bullets will need a delta time, and we will also need to count for that delta time, to have a counter, an adder, an accumulator, a delta time accumulator, which will start from 0 floating point. So if self dot delta time accumulator is greater than the time to live of this bullet, we will just say, okay, now the ID is useful. We will have to delete this bullet. So here we need the ID also. So items, which is key value. Okay, brother. Key value pair. The key is actually the ID, and the value is actually the tuple. So we just say bullet ID, and here we just replace it with the tuple. I don't know if we can just do it like that. For me it's clear, but we can probably improve it. Well, okay, if the actual accumulator is greater than the actual time to live, we can just delete the bullet ID. So we just say self dot bullets. I don't know, remove, delete. Del. Yes, maybe it's just del. Del self dot bullets of bullet ID. I don't know. So we just remove the bullet. But I don't remember if we can just delete the Python delete element from dictionary. Item, who cares? Element. Okay, so we just say del. Okay, yes, it's correct. We can just say something like that. But he's also returning. No, okay, the new dictionary. Okay, so we have the bullet ID. We have the bullet and the time to live. We don't care about the bullet, so we just use a placeholder. If the actual accumulator is greater than the time to live, we will just delete the bullet. Wait, there is a problem, by the way, because the accumulator is for the class, but we need to keep an accumulator for each bullet, because how can we just determine if okay, maybe I have an idea. Maybe we don't have to take care about an accumulator. Maybe we have to save the time on which the bullet has been created. We will make like a delta time for the single bullet. So time to live, and we will save also a spawn time, creation time. Creation time is not convincing me. Creation time, okay, why not? So let's just create a creation time variable. Creation time, which will be time.time. Let's just import time. import time maybe. Okay, time.time, which is in milliseconds. In wait, let's just check the main. We already have the main. Okay, time.time. Okay, from time is correct actually. Okay, now we have the creation time of the actual ballet. We will just have to decrease this time with the delta time. And when this item, this value, reach less than 0 or less than 0, we just delete this bullet. Okay, I don't know, for me it's not complicated. We don't need the accumulator now, by the way. So now we have the bullet itself, the time to live, and the creation time. Creation time. So what we can say? We can just say that we need to create a new creation. We need to calculate to compute a new creation time. So we just say so new time is equal to creation time minus delta time. No, wait. Yes, no, it's correct. It's correct. So we are basically saying, okay, now we have create. Oh no, wait. Delta time. We need to replicate something like we have in main. We have here something like that. We have like the creation time, which is now. We don't care about the delta time. We just need to say, okay, well, if our delta time is greater than some value, we just delete the bullet, something like that. So the creation time is per bullet, which is correct. We just saying, okay, let's just keep the starting the born type, the born time of the bullet, which is completely correct. Let's just remove now from the creation time, and if this delta time, this new delta time, so this is not, we don't care about the delta time here. We care about the now, basically. So if now, which is time.time, minus the creation time, this is the delta time, by the way. So if the delta time is greater than the TTL, we just remove the bullet. Okay, this is completely right for me. Okay, yes, if the time passed from now to the creation time of the bullet, we just delete the bullet because the TTL has expired. So we just say, yes, is maybe it's 0. We can count also 0. Delta time is greater than. Okay, this is correct. This is correct. We just remove the bullet from the ID. So we just say self dot bullets of the bullet ID. This should be correct, but we will see. Okay. Let's just update this weird documentation. Wait, we don't need it. Is clear below. Okay. Oh, yes, we can just say that time.time here. Okay, this is, for me, is good. This is good, completely good. We just need to be sure that clean on all the bullets is called in the main. So let's just call the, yes, let's just, before calling this method, let's clean okay, we need also an update method to move the bullet. Okay, so we need a bullet manager dot update, and we need to pass the delta time to the update to take care of the delta time. I think that delta time is necessary for the update method. I don't know. Delta time integer. Okay, for each bullet in, oh no, now we need to iterate over this weird stuff again. But we need just the value. We need just a tuple. So who cares about the ID? Okay, we need just a bullet, by the way. Okay, ttl bullet. We just say bullet.move. Okay, this is correct, and we pass the delta time. Delta time will be added later. And let's just let's continue with the main. So the update now is good. By the way, is not the move method. The move method is not the correct name for the player. Is the update method, which contain the move. So let's just create the update method, which will ask for a delta time. We just say self.move. For now, something like that. And yes, we will have to pass the move to the delta time. You know what? For now, let's just keep it simple and rename it in update. Delta time will be implemented later. Update and delta time. Update. Okay, now we have two update methods, which just update the position of their entity. Okay, we have the fill, and then we are drawing each stuff, but not the bullets. Let's just update the bullet manager. Dot draw. Okay, now it's more concise. I like it. Minecraft is the title of the game. We are doing Minecraft, guys. Alright. Ciao, Luca. Fucking crazy, bro. Okay, let's try the game, which should... Oh, incredible. It started. Oh, crash, bro. Fucking crash, dude. Okay, bullet.move takes one positional argument, but two are given. Let's check bullets. Bullets.move. Ah, delta time. We are not passing delta time. Wait, what? Yes, the time to leave system doesn't make sense here, as we said before. So we just delete all the delta time stuff. We don't need a counter. We are just drawing stuff easily. Okay, I don't remember about the delta time. How is just used for movement? I think that speed times delta time is what we need. Okay, now we are just switching for the direction, basically. So we are just incrementing or decrementing speed. Dir x, dir y are just 1 or minus 1. So we are saying like if we move up, dir y will be 1. So we can just by multiplying speed times 1, we just get a positive number. So we are just moving by the speed basically. So we just need to update that by the delta time to have the correct movement speed. By the way, why we need the delta time? We need the delta time so the game is not FPS dependent, okay? So we are just basically saying, okay, the game of the computer is the time between each frame can vary a lot. If we have a FPS decrement, huge FPS decrement, the time will just increase a lot. For example, from one frame to another, instead of these 16 milliseconds, we will just have something like, I don't know, 40 milliseconds. So what we can do is to say, okay, let's just multiply the difference to the speed to compensate for this delay, for this real world delay. And we can just keep a constant movement with lag in this case, because we have no I don't know, algorithm to clamp between two positions for now. Okay, but let's start. Let's continue, dude. It's easy to just getting crazier and crazier. Delta time should do the job. Let's just multiply delta time even here. So times delta time. Here we have a problem, by the way, which I'm anticipating. Speed, if we multiply 10 times 0.016, which are 60 FPS, we get a speed in pixel of 0.16 pixel, which is like not moving at all. What we can do is to multiply this value. Yes, maybe I don't know. Let's try 100. Now we will have to try. Oh, let's just move the cube. Okay, the movement for me is good. It's kind of weird. Let's just decrease the FPS to try a slow PC. Whoa. Yes. Okay, it's working as we expected. So if you have a shitty PC with can't just move a red cube, it will just lag. I don't know if you see it correctly, but it will just lag. So it's good. It's good. If we just say 120, which we will limit. Okay, is extremely fluid. Is extremely fluid. Okay, so the FPS system is working as and also the delta time one. So now we need to solve this issue. It's saying that too many values to unpack. Let's just watch. Bullets.values. Why? Wait. So bullet is a dictionary. We need its value. Let's just print. The self.bullets. Maybe I understand the error, but let's wait. Dot values. Boom. So we have this situation here. Okay, we have 3 elements. Yes, I forgot about the creation time, because this is the bullet. Okay, this is the actual bullet. Okay, we just need to add the creation time. I hate this, but maybe I can do it with double, because we don't need for example, here we don't need the creation time. We can just say placeholder. No, yes, here we need the creation time. Here we don't need the TTL, so we can just say, I don't know if in Python we can do it. Yes, we can do it. Now we have another issue. The draw method required the screen. Yes. We need to propagate the screen from the manager to its child. So we can just say screen. Let's just copy the annotation from the bullet, by the way. We don't have annotation. Who cares? And we just have to pass it here. By the way, this is far simple than dealing with a list in the main program. Okay, as you can see, the bullet is moving extremely slow. This is because this is the exact issue that we have with the new delta time. Another interesting thing is that the player is being drawn below the. This will. By the way, is crazy, dude. We can just make something extremely weird, like a game where you create spawn shit and they move. This is somewhat. Wow. I don't know. Whoa, it's hurting my eyes. Okay, just tap this shit. Okay, we need to multiply the speed by 100, as we did for the player. So now should work fine. Whoa. To speed, dude. Whee! Okay, now we need to decrease the speed. Bug or a feature? Maybe a little bit, more. Oh yes, this is quite good. Which is the speed of the player. Lol, with double sauce. Okay, okay, I like it. we now have to call the fantastic clean all the bullets method. So let's try it. Okay, I have an idea. We can just clean all bullets each update. Oh yes, this is good. This is pretty good. So we can't just have a private method which is not exposed, which is better. So we don't have to remember about this clean all bullets method. You know what? I like to make it really private. In Python, private doesn't exist. Private access modifier. Access modifiers doesn't exist. Don't exist. So this is just a freaking trick to, you know, to make it work. Okay. It crashed. Lol. By the way, it crashed when the time to leave expired, which is pretty funny. Dictionary change size during iteration. Lol. So we needed to... okay, this is pretty interesting. Pretty interesting. We can use a filter here, maybe. We can just keep track of the ID. So we can just say... well, this is easy, by the way. So to the lead will be a list, a new list called each time the method is called to. Okay, to delete. So we just say to delete.append and we just add the bullet ID. So we need to delete these bullets. So we just say we just remove these bullets. Let me drink. Good Coca-Cola Zero. Diet Coke. Coke. Lol. Okay, to delete. I said it will be easy, dude. I say that. So let's just delete the bullet. Let's just create a fucking foreign. Who cares? Allora, so scusa. For we just need the bullet ID, by the way. So we need the keys for bullet. No, wait. We have a list of deletable IDs. We can just filter them out. I don't remember what is the filter. The filter. We can just pass the function that will be used as a filter function, and the iterable to filter. So we can just say we can create we can use a lambda, maybe something like something like this. Sorry, I didn't I don't remember how lambda works, so I just did a fast example. Okay, so we needed to create a lambda, something like, oh shit, now we are creating like a huge you know the meme, the by the way, something interesting that I discovered like some days ago. If you import anti-gravity, it will open a meme, actually. Lol. If you just import anti-gravity. Obviously, if you import this, the Zen of Python will appear, which is another Easter egg, but this is a popular one. But import anti-gravity on a Python interpreter will open this meme, which is fucking crazy. You are flying. How? Python. I learned it last night. Everything is so simple. Hello world is just print hello world. I don't know, dynamic typing, white spaces. Come, join us. Join us. Programming is fun again. It's a whole new world up here. But how are you flying? I just typed import anti-gravity. That's it. I also sample everything in the medicine cabinet for comparison. But I think this is the Python. Okay, this is subtle. This is pretty subtle. You know what? By the way, maybe I'm just the only the only guy who has to read these memes like 3 times to get it properly, to get them properly. Who cares? Okay. So we need to check if our ID are the same. No, wait, I'm just getting crazier. Let's just use the map method. We need to pass a function. Maybe I'm just moving the problem away. I don't know, I'm getting crazy, brother. Okay. We have a func, we have an iterable. What we can do is okay, a function. Okay, map, apply a function to each element of a new. No, wait. Let's just iterate. I don't wanna get freaking crazy. So we just need to say, to make a zip between no, it's simple. I know that it's simple, but one thing is saying that it's simple and imagine that something is simple. Another is to do it simple. Do this stuff in a simple way. Okay, for bullet TD in okay, let's just proceed simple. For bullet TD in all this stuff, we just need the keys. So self.bullets.keys. So for each bullet TD, if the bullet TD is in the to delete list, we just delete the bullet. Okay, this will work, but is another iteration, is a double iteration. So if we have something like a huge time to live and 1,000 fucking arrows, I don't know, this will slow the program a bit, the game a bit. And what we can do is to say, instead of iterating, we can just do this. I don't know. For now, let's keep it like this. I just will remember in some future, some crazy future, that this will work. Let's just try again. Oh! Dictionary change style during this iteration. Ah, yes. I just moved away the issue. Fuck. Another way we can just we can just say, okay, dude, wait, I'm not. Oh, ciao Fabri. Okay, I just moved the issue below, so I haven't had any value. But what we can do is to create a new dictionary. A new dictionary. No, wait. What? Let's check on internet. Fuck. Python. Delete element from the. Wait, I already check it. But this will. Yes, because he's removing. During iteration. Shallow copy. Wait. Why is talking about the. Okay, so he's just suggesting something that I think I will implement. So what we can do is to create a new dictionary. Fuck, I don't know. We need to filter out the elements by their ID, basically. Okay. So we need to say something like, okay, we have the list of IDs to delete. we can just filter them out. Oh, go, brother! So we can just say, wait. Self.pallets.items. So we can have their no. Wait, brother. Oh shit! I'm getting crazier for this one. Python filter elements from list. Because it's complicated because we have a data structure. Wait, let's just proceed one step at a time. We have an ID and something like the object, the time to live, and the creation time. We can just say Bilbo Baggins. We can just say Bilbo Baggins, go to Gandalf and just order some weed. Something like that. So, if we take the keys, we need both actually, because we need the two from one side. Wait. What does it mean to delete a bullet? Delete a bullet is simply deleting an element from this dictionary, and the garbage collector will just destroy the bullet. So we just need to delete the element from the dictionary, like this. So, first of all, we just need the IDs, not the object and stuff. First of all, first important note. So this is really simple actually. We just need to say, bro, remove these keys. So, Python, remove dictionary elements by key. Oh, again. Oh yes, I'm getting crazier. Yes, is easy as this. By the way, I've already solved it. Why I'm asking this? So we can just say, let's just filter the dictionary. We need a function. Let's just call it foo, and an iterable. So we just say self.bullets self.bullets. We just remove it from the dictionary. And now we say, for each element of the bullet, I don't know if it will work. Let's just try at this point. Okay, items. We just say, okay, we have the ID and a tuple. Oh, no, wait, I'm getting crazier. This is actually far difficult than I thought. Because we have a dictionary. By the way, it's weird because I did it many times. I did it many times before, but now it's somehow not intuitive at all. Okay. You know, in this situation, I just ask, what John Carmack will do. Probably will just delete everything and write it in C. I think that a dog spawned behind me. So dictionary. Let's just search this on the internet, by the way. Yes, I don't know how to. This guy don't know how to fix this issue in Python 3. You can use the list to force a copy of the keys to be made. To force a copy of the keys to be made. Weird. No, okay, in Python 3 it will not clear the... It will not help. Okay, let's just reason a bit. Now we are... Okay, we have the ID. To delete. We need to... I don't know if you see my dog. My freaking dog, bro. By the way. Okay. Which is... Oh shit. The camera is mirrored. Lol. Okay. So, beer moment. We need to... okay, we have IDs to delete. We need to create a new dictionary without filtered by this ID. But is really complicated. So, new dict. Let's just create a new dict, which is a filter, which will be a dictionary, so a filter of the old data structure. Function is for the old dictionary will be self.bullets.items. Okay, wait, let's just ask ChatGPT, bro. I'm getting, I don't know. I just don't know, you know. Who cares? You know what? Let's just... so, I pay Claude, so let's just ask to Claude. How can I delete in Python 3 elements from a dictionary while iterating over it? Come on, Claude. I notice you're working with a dictionary cleanup operation. Your current code uses a two-pass approach with a to-delete list, which works but can be simplified. Here are a few better ways. Okay, dit.items. So he will just create... wait, what? Wait, this will never work. Okay, is dictionary comprehension. Yes. I didn't thought about it. So this is a comprehension basically, which is not the simplest way to make it works, but it is basically unpacking. He's basically adding this bullet ID, this new bullet, only if the time to live is respected, which is good. We will just copy and paste it. Lol. Yes, this is working fine. Okay. Let's... oh, yes. Thank you, Claude. Thank you very much. Thank you for all the engineer that you save every day. Okay. Now we can just fast forward to another stuff. By the way, let's just close all this shit. Now that we have a working system somehow, let's just commit. Git status. Yes, we have the PYC to delete. We needed to add a gitignore. gitignore. Ah, yes. Wait, I pushed the environment. No, okay. I pushed the PyCache. Fuck. So we needed to exclude the virtual environment and the PYC. Wait. Python gitignore template. Easy. Life is easy, bro. Vamp. Okay, vamp is exclude. PYC. Okay, PyCache will be excluded. Okay, bullet manager. And then let's just delete the PYC, the PYC folder, so you don't have to download it, guys. Yes. Let's go. So let's just run it again. Okay, now PyCache is not tracked by Git. So now we have a system to handle time to live, which is working fine, as you can see. The bullets are just disappearing, and if we print, which is a test that we can do, we print the each time we spawn a new bullet, we just print the length of the actual bullet's number. So number of bullets. Let's use an f string, and we say the length of bullets. Which is wait, what? Yes, this okay, this is working really fine. As you can see, as soon as the bullet is deleted, the list will just be okay. It's not counting the actual spawned bullet, but it's okay. Okay, it's working fine. Now we need to implement something new, brother. Something new. What can we implement? Yes, we have to fix our first bug. If we move diagonally, bullets are spawned with the wrong axis. So let's see the direction of the bullet. Let's just print the direction. The bullet should move. What is the... Wait. Maybe I'm passing the direction wrongly to the main. Get direction. Direction is actually a tuple, which should be x, and y. Yes, x, up, down, okay, is correct. Left, yes, and right is correct. So maybe I'm unpacking it wrongly. This should be an easy fix. Cheat, Bilbo Baggins 2000. Who cares? Yes. X and Y, which is good. Bread. is not diagonally correct, but is correct if we wait. Let me analyze. So the bullet is correct if we move up, down, left, right, but is not correct if we move diagonally. Ah, wait. There is a new bug, by the way. Okay. So the bullet is moving not diagonally. That's it. This is the issue, basically. Let's just print the... okay, because we don't have a diagonal direction. That's it. We need to say, okay, up, down. We need to define the diagonal directions. So we can say up, down. So up, left. So left is -1, up is -1. Then we need... I don't know if it makes sense, but we will see. Upright. And down left, down right. Down is 1, so left is -1. -1, 1, and 1, 1. Okay, this should do. And now we have to yes, this is why it's not working, by the way. We don't have the... So this is a problem. We need to say something like, if the player is moving diagonally, the direction is diagonal. It's not just up, down, left or right. Here, we are just saving the last position. So, for example, if we just say, let's just print the direction. We will see that the direction is just, if moved diagonally, is just up or left, for example, if we are moving in a diagonal up left. Up or left, which will be left because it's the last saved, probably. I don't know. So what we can do is to say, okay, if we are pressing both, so we need to check for diagonals. If we are pressing both, we just wait, but yes, because key pressed is a list of I don't remember if it's a list, scan code wrapper. Okay. No, it's a dictionary. Sorry, it's a dictionary of booleans. So what we can say, we can just say, okay, if 2 of these booleans are true, which corresponds to my keys, we have a diagonal movement. So if, let's just check for diagonal movements. Diagonal, how can I? Oh shit! In English. Let's check. Diagonal. So diagonal, diagonal. Oh shit! I'm getting I'm getting ADHD. Diagonal movement. So if keys of pygame.keyup and key left, we are moving in a direction, a diagonal direction. We just have to overwrite the direction, actually. So because the movement is correct, we don't care about the movement. So we are moving, for example, in this case, up left. Or the elif here is for the opposite direction. Is not important here, by the way. They will be all elif in this case. We are not excluding any movement if we just put elif everywhere, I think. So copy and paste, key right, self.direction is equal direction dot upright. I don't know if it makes sense, but we'll see. Pygame dot key down and keys. Pygame dot key left. Eschere. And right, down right. This should do. Let's just print the direction now. Yes, it's not moving here. It's not moving because no, I don't know. Because I'm crazy. I was pressing WASD, ASD, but the arrows works. So let's just print the. Wait, can we print the direction, the name? No, we can't, because it's not an enumeration. I was thinking about printing the name. Yes, now it's working fine. As you can see, it's working like a controller, basically. The difference between this system and a controller system is that controller has floating point. But it's working fine. This is an axis. These are axes of a controller, basically, which is pretty cool, as you can see. Wow. Okay. So now that we have the right direction, we can just should work. Wait, maybe let's check the bullet. It should work actually. Yes, it's already fixed. Lol, yoink, with double source. So let's just commit this shit. Boom. Okay. Now that we have an FPS, a working FPS, we can just okay, the fact that the bullet has the same velocity of the player is disturbing me. So let's just increase it a little bit. Let's say 12. Okay. Okay. And okay, now what the game will be will be about. Yes, there is another issue, by the way. I don't know if you can see it, but if we move diagonally, we are moving faster, and this is because of the Pythagorean theorem. So basically, this is our 2D vector, right? We can move on the y or on the x, and nothing new here, right? So what we can say, that if we move to over this point here, yoink with double source. I don't know the sides of the here. So if we want to move here, no wait, I want something bigger. Oh yes, this is good. Shit. Okay, this is good. If we want to who cares? To move here, we can just say, okay, dude, let's just come here. But there is a problem. That actually we are moving, for example, one here. I hate paint. One here and one here. But diagonally, we are actually moving 1.4. Oh shit, what? I don't know. Oh shit, fuck. Who cares? 1.4. And this is why we need the 2D vector. I think that Pygame has already a 2D vector. Pygame 2D vector. We can make it our own, by the way. It's not easy. It's not difficult. Let's check the... So basically we need to normalize the vector to solve this problem. This will solve the Pythagorean theorem. Pythagoras theorem. I don't know how to say it in English. Which is this problem here, basically. This one. Don't let me explain this in English, I don't know. So, but this is the issue here. So, let's just use the vector of Pygame, which should work. Now we need to implement a new stuff. Because our movement is just x and y, which are basically different integer values. We need to transform these values in a single data structure, which is a Vector2D. Vector2D is a data structure that is enabled by Pygame. So, by the way, this is good because we can just say Pygame data structure are more efficient than the data structure that you can create, because they are written basically in C, most of them. I'm saying most of them because I'm not sure, obviously, but Vector2D should be much more efficient, as you can see. So, okay, this is, by the way, this is pretty easy. We can just transform this in self.position is actually a Pygame math vector2, and it need two values, no, right? An x and a y. Yes, x has two constructors, a vector2 and a x and y. Yes, we can just pass a sequence of float. Maybe this will do. Let's just print this, by the way. Yes, another things. This will increase the complexity of this, because if we say self.position okay, no, this will not increase the complexity. This is cool. This is quite cool. So we can just say self.position.x is equal to self.position.y is equal to, and we can just say okay, this is already working, but here we need to change it. Okay, it was easier than expected. This is pretty cool, by the way. Yoink. Yes, Excalibur is cool, dude. Stonks. Extra stonks with double sauce. Let's check Excalibur. Yoink. Oh shit, this is good. This is okay. Thank you for the advice. Okay, let's just see if this works. For the bullet. Okay, Android Studio is getting me crazier. Let me just remove it from the my PC will crash now. Yoink. Boom. Okay, now it's working, but nothing is fixed. The diagonal movement is far faster than the directional, the simple direction movement. For the bullet, I mean. The red cube, as you can see, is already wrong. If we move to the left or to the right, is for 1 of velocity, we can say. But if we move diagonally, it's far faster. And this is a problem that we need to handle now. But, okay, bullet. So, we need to basically, how can okay, we are missing something here. We are missing an update method for the bullet, because this is, as you can see, we are saying move, but move is a method that we don't have to expose. We need to say bullet.update. We need to define a clear interface. So we can say, okay, move remain, but we need to create a new method, an update method. So we can just say self.move. Let's go, dude. The update will take delta time, and we just say here, let's solve the Pythagorean, I don't know how can I say in English, the Pythagorean theorem. Let's normalize. It returning a new vector, by the way, so we need to say self.position equal this stuff. No! Okay. And this should do. Let's check now. Whoa, 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 whoa. What? Yes, this is fucked up. Because it's not the position the issue. It's the velocity. Okay, sorry, we need to do it here. Let's check. I don't know. Nope! Yes, here, sorry. Maybe, no, wait, because it will just, I don't know the formula. Let's check. Normalize. Okay, let's try normalize in place. This is the in place version, so we can just is not returning nothing because he's modifying the position in place. Let's just trying. So, oh shit, no, the bullet are spawned on the top left. Let's just say normalize before the assignment. Yoink! With double souls. Because this is the position. This is the position. Maybe I'm getting crazier and crazier. Wait, but it's working if I don't normalize anything, right? Okay, it's working. Yes. Yes, the move method actually is correct. But I'm not sure the normalizing is doing what it supposed to do. Let me check, because yes, this is just a declaration. Yoink. Yes, this is the Pythagorean theorem. Yes, yes. Wait, this is weird. Yes, integral data. The fraction part of the coordinates gets lost, and this is correct. I'm expecting this. By the way, I'm not using a rect, so for me it's not an issue. I'm just drawing a rect, okay, but I'm not storing the information inside the rect. So I'm using floating point, whatever I want. Then in the drawing phase, it should be converted in integers, the coordinates. Because if I say the circle, it accepts, as you can see, if you see the center, is accepting a coordinate. What is coordinate object? Let's check the coordinate object. Just to be sure that we are that we are saying something correct. Pygame coordinates. Wait. Wait. Let's just okay. Let's just check this. Boom. Coordinates. The center, yes, is a tuple of integer or float, but the draw, I suppose, will. This is not important, by the way, but it's just to check if we are reasoning right. Because I'm expecting, because if I draw something on the screen, I don't think that we can use floating points. But seems that the draw calls are made with the floating points in Pygame. Yes. Okay. Lol. The drawing algorithm was improved to look more like a circle. Wait, what? Yoink with double sauce. So before Pygame didn't draw any circle, seems. My dog is searching for a sleeping spot. Pygame.draw circle. Okay, so let's wait. I forgot the problem. So we need to solve the Pythagorean issue, and the vector is not working fine. Let's just continue reading this. Okay. Yes, I was here. The fraction part. Okay. Just don't read this phrase, please. If you want to store object position, this is talking about this floating point stuff, which is getting me crazy. Synchronize the Pygame rect object. Okay, round. Who cares? Let's check for normalize. Okay, the normalize. Okay, so the direction is normalized. The speed is multiplied after later. So we need to exclude the speed from the normalization. Holy shit, I don't know a way to do it properly. Let's just remove it and let's just say something like, okay, self.position dot normalize, and then we just multiply. Yes, there is a multiply, I think. How can we Pygame multiply vector2 complex operation. Wow, a vector2 is a complex operation. Okay, you can just use a lambda. Multiply 5 to all of them. So he has a vector. And he wants to multiply something by the vector, which is what I want. Wait, but why there is not a multiply method? I think that is easier if we made a new data structure by our own, but multiply, there is no multiply method. How is that possible? Let's check it a bit on the documentation. I'm not sure that that this is correct. Okay. Element-wise method, what the fuck? What the maybe element-wise is what I'm searching. What I'm searching for. but does it make sense, the name? Element-wise is doing vector element-wise proxy. No, wait. No, wait. Because he's supposing to multiply two vectors together, which is not what I want. I want to multiply each coordinate of the vector. Let's ask ChatGPT, because this is a nice, a good sorry, Claude, because this is a good question, by the way. Sorry, PE, the folder PE stands for prompt engineer, because you know, every software engineer in 2020 ever is a prompt engineer. So how can I multiply each coordinate of a vector 2D in Pygame for a value? Okay, the question is prompted weird, but who cares? We can just say, okay, we have a vector. No, shit, is that easy? Is that easy? Holy shit. I was over-engineering everything as always. So we can just say the position, the vector, so self.position times equal speed. Lol, was easier than I thought. Wait, what? And then we can just before, let's see if it work. If it working. It's not working. I'm spawning bullets, but nothing happens. If I remove this, yes. It's not working because it's not doing what I want to do. What I want it to do. If I just multiply the speed, it should work. Yes, and if I use the new strategy of the vector multiplication, it's not working. So new position self position is new self position is self.normalize times speed. Let's try it. So yoink. Okay, now something is happening, but it's something weird. No, this is not the solution, seems. But is a by the way, this is the same. This is the same. Not no, this is not the same. Yes, this is the same. The same as your solution. And this wait. Okay. Yes, because it's not the value. Who cares? No, okay. So how can we fix it? Pygame? What the fuck? And this should be an easy problem, but if we implement a new vector data structure, will be far easier than using the Pygame one. But I would like to solve it with Pygame. Let's check it. So let's just ask ChatGPT. I don't care. I don't really care, because I want to know the answer before implementing my eventual data structure. Wait, what? Claude. How can I normalize the diagonal movement? Yoink! Here. Okay, he is converting the direction as a vector, but this is not important for me. Ah, okay, wait. Okay, so if we have no direction, which is actually not my case because we have always a default direction, because we are taking this direction from the player, and the player has always a default. Let's check just to be sure. Yes, he is always the right as default position. Who cares? So what he's doing, he's basically normalizing the direction, which for me is not a problem, which is always 1 or 0, basically, positive or negative. And then, yes, but this is not my problem, wait. He's getting, the speed is the problem for me. Let's try its solution, but I think that won't work. But let's try it. Shit. The bullet. Just to check. And it works. What the fuck? What the fuck? We can just remove it, this check. And we can just say dot normalize here. So the direction was my problem. But direction is always a normalized value. Now we have the movement. Okay, the movement. Maybe this was the issue. Okay, the movement is the direction, which is I don't think that is the issue. Times self dot speed times delta time, which is correct. I'm not getting why the is working. Because he basically okay, wait. He's not normalizing the position, which this is this was a logical error clearly, because if we normalize a position which is, for example, we are okay, sorry for the paint again, but we are, for example, here. No, wait, fuck paint. Let's just use the crazy Excalibur. Okay, so yes, if you can draw, maybe. If we are, for example, we are spawning a bullet, and the bullet is is something like here. Lol, yoink, is here. If we normalize the bullet position, we are actually translating the bullet here at, for example, 1. So this is the error that the wrong position was that. I was reasoning wrong. But since we was adding... yes. I am understanding the issue. Because we was normalizing the vector already computed. So we were normalizing the position, but if we normalize the position, we are just spawning the bullet in the wrong position at the start of this 2D vector. We need to normalize not the position, but the value that we are adding to the position, which is what Claude did. Claude normalized the direction, which is not clear to me, honestly. But this is the point, seems. Direction for me is not clear, by the way. Let's just print the direction before the normalization. Div mod, what the fuck? Print direction before normalization. Let's normalize in place. Okay, let's check it, because I'm curious, you know. Is is equal, by the way. And we solved the issue, because now I don't know how it's possible. I'm sorry. Who cares? Let's go forward. But I'm not understanding this, because direction is always normalized. If we remove this normalization, we will get the same fixed solution. Yes. No, now it's not fixed. What? Now it's fixed. How is this is that possible? But if our directions are like this, why normalization is necessary? Yes, is already as unit vectors. Normalization isn't necessary. Yes, because our values are not arbitrary. Exactly. But the movement is changing if we normalize. You know what? Let's just... but the question is, how I... Wait, what? Why is it 0 point... Ah, no, wait. The normalization actually happened. Because here we have arbitrary values, not unit vectors. What the heck? So this is why. Okay, now I get the issue. Because normally our direction was not always 1 or -1. Because was maybe, I don't know. You know what, who cares? Let's just keep it like this. This is the solution. And we agree on this. I don't know the exact solution, but we can go forward. The normalization is the actual solution. The fact that we had already unit vectors, and we are normalizing unit vectors, which doesn't make sense, is not clear, totally clear. Is clear because we are not getting a unit vector, as you can see. 0.7 is not a unit vector. So this is the problem. But we can do just last verification. Why not? Self.direction. We can say before and after again. And we should see, in diagonal movement, we should see some difference. Okay, diagonal is 0.7, as you can see. Normalized. What? Is normal? Ah, yes! Oh my god, yes. Because if we say 1, if we imagine the square of Pythagorean theorem, we have something like this, right? Something like we are moving in this point here. This, even if I even drawed, this is 1.4. We need to remove the 0.4. So this is why it's removing the 0.4, which is 0.7. Okay, this is because this is 0.7 to be normalized. Okay, this is correct. Now I'm getting why. So we need to normalize the direction, even if it's in unit vectors. We need to remove the 0.3, 0.4, 0.3. Okay, this is cool. This is pretty cool. Yes, now it's working. Let's do it for the player, which should be pretty easy. So now instead of x and y, we just say self.position is equal a pygame.math.vector2. Vector2 is starting position as 50-50. Now we can say self.y, we just replace it everywhere with self.position.y. And the x the same. Yes. Now we have to take care about the normalization, which will be on the direction, I guess. But we will normalize the update. The update. So self dot position self dot position will be normalized in place, but we need to do it before the okay, because here we are doing another reasoning. We are saying we are not using the direction to move, basically. We are just using the direction to signal to the game the player direction. We are just using the speed and the delta time. So maybe here is enough to just normalize the position. Let's okay, no, it's not working. Yes, because we are normalizing the actual position. This is why it is not working. We need to normalize the value that we are adding or subtracting to the position. Yes. By the way, I'm duplicating this speed dot delta time times delta time like 4 times. Let's just say movement, like in bullets. Let's just normalize it. How? Oh shit. Wait. Let me understand. I mean, I can do it with a data structure, a custom data structure. I cannot use Pygame. I don't know why. How can I normalize diagonal movement here? Yes, they're cardinal movement because x and y velocities are being added together without normalization. Yes, and this is the issue, which is okay. Okay, he's determining the vector based on the input. The movement. Ah, okay. Yes. He's normalizing the movement before adding it. Yes. So this is the solution. Holy shit. All right. So we are able to do it. We can just say. We can. By the way, this updated method, is getting really huge. We need to. I think that we need to decouple the direction, the getting phase of the direction, and the position increasing or decreasing. So modification. So we need to say set direction and move. We need to decouple these two phases. We need the delta time, I think. Yes. So for the movement, we will need the delta time. For the direction, no delta time, just the key pressed. The issue with decoupling this phase is that we need to maybe to decouple some, so to double some if. Okay, so now keys. We need to pass the keys also. Keys and the keys. Okay, let's create. Okay, the easier one, I think that is maybe the move. Let's just create maybe the set direction. Set direction is okay. Based on the keys, we just need to set the direction. So all this block will be moved here, which is the diagonal movement. We need also the keys. Keys, which is a dict. Is not a dict, but is a subclass, I think. Scan code wrapper. Who cares? Is a dict. now we need, since it is a subclass, by the way, we can just specify the base class, one of the parent class, because it will works like an interface, basically. We can just use, if we specify the father, we are not losing any information, basically. Okay, these are for diagonals. We also need the normal movement. So this is where the code will be duplicated, but you know what? Who cares? I prefer to have all decoupled. This is a trade-off, I think. Bam 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 bara bam bara bam bam. Ah, by the way, if we have a direction here, we can just return, preventing other if. Because if we are going diagonal, we can just say, if we have a diagonal direction, we can just return without checking the normal direction. So we can maybe say something like this. So self dot, the expense is to reset the direction, but who cares? Because we are setting direction none. So we can just say that if we have a direction, we just wait. No, this is not an improvement at all. This is because we will make. No. Okay, we are not doing, because okay, with one if we can save 3 other if. So we can just say if self dot direction, we just return, and now we can just say if self dot keys and the direction. Well, this is pretty. Okay, I don't know a shortcut to save time. Just be patient. Bam 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 bam. Nice and chill. Okay, we are saving basically these blocks. This block, if we have already a diagonal direction, which is cool. Now we need to. Wait, but this is nullifying the default direction. So we just. No, okay, this is cool, by the way. This is pretty cool. We can just say that if we have no direction, we just set the direction equal right. This seems to be an overcomplication of the system, because now we have a positional clause. The benefits are that if we have a diagonal direction, we basically skip everything, every if. So there is a branches benefit, basically. I don't know how the Python compiler, because we are on a level of abstraction that is preventing a better analysis. I don't want to do it now, but I think that we are skipping many branches, all these branches. If we just return here, which is an improvement each frame, a huge improvement of some milliseconds. I'm not sure, but I think it's something like that. Okay, the move, we need the keys, which is a dict. Okay, now my freaking dog. So let's okay, the move is just doing what is it's supposed to. Should work, by the way. So we can just move forward. Yes, these are now for example, set direction is private, so we can just move it down. Move is private. I'm using the convention that private methods are just below. Whoa, it's weird. What happened? Oh no, okay, it's working. What? Ah, yes, because we don't have player X, player Y. Player position dot X. We are actually exposing. Okay, you know what? I don't want to expose the position, the direct position. We can create a property, an X property. This is the get. So we are not exposing the position, we are just exposing its coordinates. This is good because on the caller side we don't know what objects are dealing with. We are dealing with. So we just return the X and Y. But we need to hide the position. By the way, Python doesn't don't have, I don't know, lol. Let me check. Wait, I'm really shit in English. Does not have, Python doesn't have private HS modifiers, basically. So to define the private, you have just to doesn't exist. Okay, private is not existing in Python ecosystem. So you need to put the double underscore before something, before a name of a variable, so of a field or of a method. This is basically a workaround, because is just pre-append the name of the class to the name of the attribute. So if I want to get the, for example, something private, I can just say player dot, and you can see we have the, no wait, so for example player dot move here is exposed, but we are in the same module. Let's try in the just for fun and profit. What? For example, we can say player dot on the instance. We have access to private methods, but I think that if we call the private method, I don't know. Let me check. Which doesn't exist. Okay. Yes, this is a workaround, but is not great as the double underscore. You know, one is two is better than one. Yes, yes, we need to pre-append this stuff. For example, the name of the class with an underscore before, and then we can access the, which is mangled. Weird. But okay, let's just was a little recap. Let's just check. Okay, it's crashing again. Ah, yes, because I need I forgot about the Y. Lol. Property now should work fine. Yes. Okay, we are over-engineering this game quite a bit. Note that the default is not the last direction, but is the right. This will be another feature, but who cares? For now we don't. Let's make a to-do, by the way. Let's make a to-do, which is important. Why I didn't vote? So. Fuck Trello, all these tools. Let's just use our old Markdown. What we need to do? Let's make a checklist, right? We need to save the last player position, basically. Wait, why? Yes, I have Copilot in Markdown enabled, lol. So we can, no wait, so we nothing. We just save the last player position to keep. to keep when the player stop. Okay, this will be a feature, for example. We will need to add some sprites, enemies. Let's create an enemy. So an enemy has a speed, predefined speed for now, which will be like 5, and okay, and then other characteristics. Wait, you know what? All these stuffs are. We need to move some of them in a base class, I think. Who cares? For now, we will keep it simple. Okay, init. So what enemies? So the speed will be. You know what? Let's ask for the speed. Let's ask for the speed. So self.speed. And now let's create the main methods, right? The update and the draw methods, right? Now we need to think about what is an enemy in this game. Basically, an enemy will have a rect, for example. So we can say just yes. Let's import Pygame. Basically a rect. I don't remember the rect. Let's just copy the player. We need a screen and a color, which will be the player will be blue. The player is never red, bro. He's always blue. We don't have blue. Ah, yes, we have a class that abstracts the the external libraries are imported later after the internal one. So let's just be compliant to PEP8. Who cares? Okay, we need a position, obviously. So position. So let's just create a new vector. This position will have a default value, but we will need something random, I guess. Lol. Let's import. I don't know about the Python math. Maybe it's random. Import random. Ah yes, it's random. So is random.randint. Randint return a random integer in range a and b, including both endpoints. So we can say just so for the x we can say, you know what, 0 to you know what, I want a circle. Let's just who cares? Randint we have 0 to the screen size, I guess, which is expressed in pixel. Is expressed in yes, is expressed in pixel. So we need to divide. No, okay, it's correct. Is correct. It will be the screen size. By the way, the screen at this point we need the screen. We need to ask for the screen, which is a Pygame display. Pygame display. No, wait. Yes, is a display is an object, right? No, is a module. What is the screen? It's a surface. Yes, 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 yes. So we just say self.screen equal screen, and instead of I'm breaking the interface, the drawing interface, because in each interface we just ask for the screen, but now we are asking for the screen in the constructor. I hate this design issue. Who cares? You know what? We just say we need, because here there is a design issue here. We are to getting the screen width and height. We are just asking for the screen, which is not correct. We should have something like a constants module that's define the screen. Wait, maybe in the main I already. No, here. This is an issue. So we just need the screen height. We need to decouple. I don't remember. Holy shit. Height, which is 1280, and the screen width. Width maybe is before the height. Alright. Or height. Lol. Yoink. So now we need to import. This for me is better. From constants, import screen width and screen height. Boom. Okay, and should work the same. Oh, nope. Totally nope. Yes, because the width is I inverted width and height. Lol. No, wait. Yes, lol. Okay. Now let's just create. Okay, now we can just import the width and height. Yes. Quindi, so from constants import. Let's just import the screen width and screen height, and we can just say which the x will be screen width, the y will be screen height. Yes, oh, yes, oh, yes, oh, yes. And now we just assign to x and y, and now we have a nice vector with a nice position. This is cool because we can just say enemy, if you hit the border of the screen plus your radius, just plus the half of your size, you just turn into another direction. So you can just move indefinitely. So the enemy will have a speed. Okay, the height and width will be predefined for now. Self.height will be I think 25, yes, which is half of the player height, and the width will be 25. Yes, we are dealing with squares. Okay, let's just draw. Okay, it's already set up. Let's just instance an enemy. By the way, as far as I'm going, I need something like a spawner, a class that's you tell the class, dude, just spawn something, and the class will spawn this something. But I need to make another. Maybe you know what? Let's just add the spawner. Spawner will just you told the spawner what to spawn and where. Oh, what? The spawner will spawn the object in the position you told it to. Lol. Classic useless copilot suggestion. Enemy. Okay, the enemy need the speed. The speed will be yes, so let's just make it optional. Because, you know, I don't remember, for example, the player velocity, the player speed, which is 10. The player speed is 10, so we can just say 5. They are slower than the player. Okay, now let's draw the first enemy. As you can see, we are like creating some section here, and this we can call it scene. This is a scene. Sorry, the update. This is a scene, no? This class, this main class. It's like a level of the game. So we are updating, we are clearing the screen, and then we are drawing, which is, I think, is correct. So enemy dot draw. For now, no update. Why not? Okay, the interface is okay. The drawing interface. We have not defined any interface, but it's okay. Now we need to let's just start. Okay, we have a blue. Why blue? Shit. Red. Now we have an enemy clearly, which has spawned outside of the screen. Seems. Ah no, okay, was behind. Ah no, wait, what? Okay, the enemy is behind the player. For me, is good. Oh shit. Okay, it's good. And we need to basically. The player is moving too fast, by the way. Let's just decrease maybe 7. Because you don't have control. Okay, now it's better. A bit too much. By the way, you can have a float at this point. We know that Pygame accepts float to draw. Oh, what? The left direction is broke. Lol. Why? Ah, yes. Maybe I just wrong some of these. Up, down, left, right. So up, down. Yes, the direction of the bullet is wrong. Ah, yes, maybe it's the default one. Maybe the bullet is getting the default direction. Sorry, the none direction. If we replace this with by the way, yes. Why I'm doing this? We can just say this no, no. Because if we remove, we are losing this particular if. So we can just say, you know what? Who cares? Let's keep it simple. I'm overcomplicating everything. So let's just keep it simple. We don't want to catch weird bug. So okay, now it's working fine. The issue was about the. No, wait, it's not working diagonally fine. But it's working. The diagonals are wrong. Ah, yes, because we are overwriting in the wrong direction now. We needed to. Yes, this will fix. We needed to check for diagonal at the end. Okay, now it's working again. We need to move the player, the enemy, sorry. So we needed to say an update. Update will be AI driven. Whoa, with some sparkling AI. Let's check the chat sometimes. Yes. So we need to add some AI sparkling magic. By the way, guys, in 10 minutes I will close, I think. Okay, let's just update the enemy position. The enemy will move in a random position, so we need to we need to define some steps. So something like self dot change position, and then self dot move. But so we need to get a new position, basically a new direction, sorry. Not change the, okay, so we need to okay, we don't need a direction actually, because we have two options. We can just say, okay, let's define a new endpoint to reach, and this will be probably the better one, the better. Or we can just select a random direction and follow that direction for like some pixel. But this is not correct, because if we reach some object that we can't pass through, we will need to change direction again. No, okay, let's just make the first one. We need to decide for a destination. So, decide destination. We will need a new destination. So let's just... destination will be a vector2. So, self dot destination will be a vector2. Vector2 of what? Of some random values, basically. Yes, something like this. We can just replicate the random, and will be a new value. We can say something like this. Now, let's create a method. Let's create a get random vector. Vector2. Okay, that's cool. That's good. We are obviously talking about a vector2. X and Y. So we just pass the yes. Not X and Y, but we need a range. Or a tuple, maybe. I don't remember about the range, by the way. Who cares? Let me check. What does the range? Is an generator returns. Is an object. Is a range object. Cool. Is a class range. So we can just call for range. We can just say, okay, just give me a range, which is of type range. And we can just say here, position is. We just return the new vector, by the way. And range dot start. Cool. Well, this is cool. Range dot stop. This should work. Position will be self dot get random vector2D, and we say just screen width and screen y. Okay, a range of screen width and screen y. Screen I, sorry. Y. And also for the destination will be the same. Oh yes, this was just an engineering how can I say? Wait, let me learn English. Capriccio. An engineering whim. Lol. An engineering whim. Okay, so we get a random, two random vectors. The position, which will be needed to draw, and to update the movement. Also we will need the delta time. By the way, these are all interfaces, so... And we decide a new destination. The destination... well, this is quite easy, by the way. We don't need a method to do this. We can just say this. We can just copy and paste it, and this will just initialize. We initialize as a new vector of 0, 0. Also none. Who cares? And now we just need to use it in the move method. Now we need to move towards the destination. This is not easy, because we need to clamp, basically, right? We need to move in time towards this destination. And we need to calculate the distance between 2 points, basically. And move over... how can I say? We have to constantly move towards the destination, basically, until we have reached the destination, which is a simple if. If destination is equal our position, we have reached the destination. And so now we have a first. Okay, so if we have reached the destination, if self dot destination reached, we will just change the destination. It's just a boolean. And now, if okay, we change the destination, we need to move. So to move, we need to I'm not sure how can we do that. So first of all, we need to calculate the distance. So the distance between me, the enemy, and the destination point. Distance between two vectors are actually, I think that is just a... You know, let's just recap. Distance between 2 points. What? Between 2 points. Euclidean distance. Which is this one. We have 2 points, we just subtract, sorry, is the below one, 2 dimension. We just subtract x and y squared, we get the square root, and we add them together. So this is the distance. Yes, because we have 2 points. Okay, let's calculate the distance. So we need the square root. Oddio, I don't remember the square root in Python. Math.squirt. Let's just import math. Okay, we need a value. The value will be the let's just use POW. The power of 2 of of our value, basically, which is yes, sorry, I'm a bit tired. Is self dot position dot x plus the destination x, not plus, sorry, minus. But this is a bit complicated. Let's just make x and then y. So x is this, y is this. Yoink. Now we need to make the square root of their sum. And now we have the distance. So, sorry, let me just check the POW method, because I don't remember if the default is 2. No, wait, is math? No, it's not math. Ah, wait, was not under the math module. Yes, no, exponent is required, sorry. Ah, wait, was... what is the difference between... lol. So we are getting a float like this. Let's just use the POW. Okay. By the way, this should be good. Okay, now we have the distance. We need to move constantly towards the distance. Constantly means we need to move with a speed times delta time. The speed is speed times what? Yes, times 100, because we are dealing with delta time, which will multiply by a fraction. So we'll decrease the speed, so we need to multiply by 100. So, what we need to do? Let's just close this enemy movement, and then we can go home easily. The movement. The movement. So we have a distance. Now, let's use xcalidraw. We need... okay, there are shortcuts. We need... okay, there is a point, but who cares? No, let's delete it. Oh, shit. So we have two points. We have 2 points. We have a position, a starting position, and a destination. And we need to reach the destination, but we have the time as our constant to calculate, because okay, we have the distance. The distance, basically, we are talking about a stroke. So we can just divide the probably. I'm just guessing. We just divide the the stroke by the stroke. How can I say the stroke magnitude? Yes, I think magnitude is the right magnitude. Okay, the stroke length will be wait, is a vector magnitude? Hmm. Yes, is the length. All right, all right, all right. So I was right. The magnitude of the vector. So the magnitude, we can just divide the magnitude of the vector by. By the way, I realized something. Here we are just calculating the distance, but we need the. I don't know, guys. You know what? We will probably continue next time. I'm just tired, dude. I'm freaking tired. What? Ah, yes, it's a range. Oh, what? Lol. Yoink. Yes, we just have the weird red button, but it's working everything, so who cares? I mean, what we have in local, just to say if we can just push everything and why not. So the next to do, by the way, will be to fix the enemy movement. So let's just add it. Fix enemy movement. So do we need a vector as distance to distance or the magnitude or the distance is enough? The distance as difference is enough. Magnitude, I mean the vector, I mean the magnitude, right? So what I'm doing? Ah, lol. Do we need a vector? So the magnitude of the vector as distance, or the distance as what? Or the difference as the distance is enough, or the difference is enough. Let's just remove. Fix the enemy movement. We will take care the next time. Who cares? So we need to fix the enemy movement. We need to when the enemy hit a border, a screen border, we flip the direction. Then we say when the enemy has been hit by a bullet, it should be destroyed. This should be fairly simple, by the way. We will need an enemy's manager. Then we save the last player position to keep when the player stops, and which is good. We add some sprites to add some juice to the game. We will need a spawner. This will be a system, a complicated system, I think. We will next time we will add some sprite. By the way, guys, thank you very much to whoever watched me, which I'm just a backend engineer with that is trying to make a game. And that's it, dude. Have fun, have a good night, and see ya, guys.